All right, so we're diving into something pretty fascinating today. You know those large language models we keep hearing about? Those AI systems, writing poems, translating languages, even coding websites.
LLMs, yeah.
LLMs, they're everywhere these days, and they're impressive, right? But there's a bit of a paradox with these systems.
Yeah, it's like they've got all this information, mountains of it,
Yeah,
trained on the entire internet, it seems like. But then
but then they miss the mark sometimes. Like they can't quite connect the dots.
it's fascinating, isn't it? Like having a library, a huge one, but no Dewey Decimal System, no librarian to guide you.
Tell me about it. A library full of unsorted books is any researcher's nightmare. But thankfully, researchers are onto this, and they're exploring this idea called Retrieval-Augmented Generation,
Hmm.
ARGO for short.
Catchy, right?
It is, and it's a pretty elegant solution when you think about it. It's like giving our LLMs a superpower.
Instead of just the information itself, we give them a way to access it.
Exactly. The ability to tap into external databases, all organized and ready to go, like giving them a direct line to the Library of Congress.
Precisely. Oregon connects an LLM to a separate massive database. And that data, it could be anything. Research papers, news articles, medical textbooks, you name it. And with ORIG, the LLM can retrieve hyper-relevant information on demand. Makes its responses way more accurate, more comprehensive.
It's like giving them that missing librarian, right? They can finally find the right book for the question at hand.
Right, the right information at the right time.
And this research paper we're looking at today from Microsoft Research Asia, it really dives deep into how to make the most of RAG. They have this framework for categorizing the types of questions LLMs can answer when they've got access to this external knowledge.
There are 4 levels of queries, right?
Yes, the 4 levels of queries, and it really is a bit of a wild ride seeing what these systems can do.
And what I find interesting is how these levels highlight the increasing complexity of what LLMs can handle with this external data. It's not just remembering facts anymore, it's about reasoning, problem solving even.
Okay, so let's break it down a bit. Let's say you're asking an LM about the Olympics, something like, where will the 2024 Summer Olympics be held? That's their level 1, an explicit fact query. Straightforward, right?
Exactly. The answer, Paris, is a clear fact, easily retrieved from a database, like looking up a word in a dictionary.
Simple enough. But things get more interesting with level 2. They're implicit fact queries. Now imagine asking, what is the majority party in the country where the 2024 Summer Olympics are being held? Still need that external data, but it's not just a simple lookup anymore.
Now the LLM has to make some connections. First, it needs to retrieve that the 2024 Olympics are in Paris, then connect Paris to France, and then find the current ruling party of France.
It's a process.
It is a multi-step process of connecting the dots.
You know, this reminds me of trying to research a historical figure a while back. I swear it took like 5 different sources just to piece together their basic biography. Felt like I was stuck in level 2 reasoning the whole time.
And that's exactly why we have LLMs, right?
To do the heavy lifting for us.
Exactly. But here's where it gets even more interesting. Because we're not just talking about finding facts anymore. We're talking about LLMs understanding the why behind the what. And that's where level 3 comes in.
Okay, level 3. Give us the lowdown. What's so special about these queries? Level 3, huh? So we're getting complex now. What's the deal with these level 3 queries?
Yeah, level 3 is where things get really interesting. We're moving beyond just finding facts.
I'm going deeper.
Much deeper. Now we're talking about interpretable rationales. The external data, it's not just giving facts, it's providing instructions, guidelines, blueprints almost.
So instead of just spitting out an answer, the LLM is actually looking at how the decision is made.
Exactly, the logic behind it, the why behind the what, as they say.
Okay, I'm intrigued, but give me an example. Make this concrete for me.
All right, imagine a query like, how should a patient with chest pain and, let's say, these specific symptoms, how should they be diagnosed? Now, the LLM needs to access a medical database, but it's not just about symptoms, right? It needs the diagnostic criteria, the decision-making process a doctor would use.
Oh, so we're teaching LLMs to think like doctors now.
In a way, yeah.
That's both incredible and a little, I don't know, unnerving.
It's cutting-edge stuff, that's for sure.
So how do we even start doing that, teaching an LLM to make those kinds of judgment calls?
Well, the paper talks about this cool example, text-to-MDT, it's called.
Catchy.
Right. And what it does is it takes these medical texts and it automatically extracts decision trees from them.
Decision trees,
Hmm.
like flowcharts.
Exactly. It takes those dense, complex medical guidelines and turns them into something much more structured, something an LLM can grasp.
Ah, so we're translating those medical textbooks into a language the LLM can understand.
Precisely.
That's clever. But this isn't just about healthcare, right? I mean, you could apply this to so many different fields.
Oh, absolutely. Imagine the possibilities in customer service, for example. Instead of just pulling up FAQs, an LLM could access a company's entire customer service handbook.
Oh, that's interesting.
Right, and then it could handle those really complex issues.
With nuance, with that human touch.
Exactly. Or think about software development, an LLM that can debug code.
Oh, now that would be useful.
Right, referencing a whole knowledge base of past bug reports, solutions, even the reasoning behind each fix.
Wow. So we're talking about a whole new level of AI assistance.
Level 3 is all about empowering these LLMs to make decisions, solve problems, using that same kind of logic, that expertise that humans do.
It's pretty mind-blowing.
Yeah.
But I have to ask, it sounds like there's another level.
There is, and this is where things get really, really interesting.
Okay, you've piqued my curiosity. What's level 4 all about?
Level 4, that's hidden rationales, and this is where we push the boundaries of what's possible with LLMs.
Hidden rationales. It sounds like we're entering the matrix here.
It's a good way to put it, because with level 4, the reasoning, it's not spelled out. It's not in a textbook or a set of guidelines.
Okay, now I'm lost.
It's implicit in the data, buried within it.
Give me an example. I need a real-world scenario to wrap my head around this.
Okay, imagine trying to predict economic trends, right? You've got a massive data set, financial reports, market data, news articles, tons of information.
And somewhere in there.
Somewhere in there are the patterns, the causal relationships that actually influence those economic shifts.
Right.
But no one is going to hand you a formula, right? It's up to the LLM to uncover those connections.
So it's like you have all the pieces of the puzzle, but the picture on the box is gone. You have to figure out how they all fit together.
A perfect analogy. It's a real challenge.
That sounds incredibly hard. Like, how do we even begin to teach an LLM to think that way?
That's a million-dollar question. And it's what makes level 4 so fascinating, so important. It's like teaching an LLM to become a detective, to look at all this data and piece together clues, find patterns, to solve the case.
To go beyond just understanding, to actually extracting new knowledge.
Exactly. That's level 4. And it's a game changer.
Level 4 sounds like the holy grail of LLMs, getting them to think like, well, experts in any field. But how do we make it happen? What are the tools we can use to crack the level 4 code? All right, so level 4 queries are LLM Sherlock Holmes trying to solve these incredibly complex cases. What's in their detective kit? What tools are we using to train these LLMs?
So the paper lays out 3 main approaches for this. For giving LLMs that deep knowledge, those hidden rationales, we're talking about offline learning, in-context learning, and fine-tuning. Each one has its own strengths and weaknesses. It's like giving our LLM detective a different set of investigative tools.
Okay, I like this analogy. So let's break it down tool by tool. First up, offline learning. That sounds fairly self-explanatory.
It is, in a way. Offline learning means we train another model, a separate model. And its job is to find those hidden rules, those guidelines, in the data before the LLM even sees it.
Interesting. So it's like pre-processing.
Yeah, exactly. Like giving our LLM detective a summarized case file, all the key insights, the potential leads, all highlighted, ready to go.
Ah, so it's about giving them a head start on the investigation. I like it. What about in-context learning? That sounds a bit more, I don't know, intuitive maybe.
It is. With in-context learning, we're basically saying to the LLM, look, you're already pretty good at spotting patterns, right?
They are trained on a lot of data.
Exactly. So we say, here are some examples of how these hidden rationales work. See if you can find the connections.
So it's all about choosing the right examples.
It is. It's like giving our detective a few solved cases. Show them the thought process, the subtle clues.
Ah, learning by example. Very cool. Okay, and our last tool in the LLM Detectives Kit, fine-tuning. That sounds intense.
It can be. Fine-tuning is definitely the most intensive of these approaches, because now we're talking about retraining the LM itself.
Oh, wow. So not just adding information, but actually changing how the LLM learns.
Exactly. We're tailoring it to the task at hand. Think of it like putting our detective through a specialized training program.
Honing their skills for a very specific type of case.
Precisely. Of course, this takes a lot of resources, a lot of data, a lot of computing power, but the payoff can be huge.
Right, it's like anything else. You get out what you put in. This has been a journey. We've gone from giving LLMs basic facts to, like, training them to be expert detectives, uncovering hidden patterns in data. It's amazing. But let's bring this back down to earth for a second. What does all this mean for us in the real world?
And that's the key point, really. these query types, they're not just theoretical. In the real world, problems, they're messy.
You rarely fit into neat little boxes.
Exactly. Take our economic prediction example from before. Yeah, it needs uncovering hidden rationales, that level 4 thinking. But we also want those explicit facts, the current market conditions, maybe even some expert guidelines. It's about using the right tools at the right time.
So the real magic happens when we combine these different RX techniques
Hmm.
to tackle those really complex, multifaceted problems.
Exactly. That's what's so exciting about this research. It's like, how do we design systems that can move between these levels of complexity seamlessly
So they can retrieve a simple fact 1 minute, then uncover some hidden pattern the next.
and use all of that to give us truly insightful answers, helpful answers? That's the future.
Like, we're not just building smarter machines, we're building machines that think more like us.
Yeah.
But with the added benefit of, superhuman information processing, it's mind-blowing.
It is an exciting time to be working with LLMs, that's for sure.
This whole deep dive into retrieval-augmented generation has been incredible. We've learned how to give LLMs a serious upgrade, moving from simple Q&A to real understanding, to reasoning. If you're as fascinated by this as we are, be sure to check out the full research paper from Microsoft Research Asia. We'll link to it in the show notes. Until next time, keep asking those big questions. Keep exploring, because who knows what hidden knowledge is out there just waiting to be uncovered.